Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Data Structures in Python, Part 2, Implementation of Stack using List, Practical Implementation, for the Class 12 students of Computer Science. So, let's dive in and get started. Let's look at Example 1. Write a Python program to implement all basic operations of a stack, such as adding element, push operation, removing element, pop operation, and displaying the stack elements, traversal operation, using lists. Now, look at the code. In line 1, stack equals empty square brackets. This line initializes an empty list called stack, which will be used to represent the stack data structure. Initially, the stack is empty. In line 3, while true. This starts an infinite loop. The code inside this loop will keep running until a break statement is encountered. In this case, it allows the program to keep executing stack operations until the user chooses to quit. In line 4, print stack operations. This line prints a message indicating the start of the menu for stack operations. The \n is used to print a new line character, creating a line break for better readability. In line 5 to line 8, the next 4 lines, print 1. Push, print 2. Pop, print 3. Display, and print 4. Quit, print out the menu options for the user to choose from. These options include push, pop, display, and quit. In line 10. Choice equals int of, input of, enter your choice. This line prompts the user to enter their choice by displaying enter your choice, and reads the input as a string using input function. Then, it converts the input to an integer using int function and stores it in the variable choice. In line 12, the if statement checks the value of choice to determine which operation the user has selected. If choice equals 1. If the user chose 1, push, the code inside this block is executed. In line 13, item equals input of enter element to push. It prompts the user to enter an element to push onto the stack and stores the input in the variable item. In line 14, stack.append of item. It adds the item to the top of the stack by appending it to the stack list. In line 15, print f item pushed onto the stack. It prints a message confirming that the element has been pushed onto the stack. In line 17, the elif statement checks if choice is equal to 2, pop. If so, it performs the following. In line 18, if stack. It checks if the stack is not empty. If the stack is not empty, that is, it contains elements, it executes the code inside this block. In line 19, popped_item equals stack.pop function. It pops the top element from the stack using pop function and assigns it to the variable popped_item. In line 20, print f popped element, popped_item. It prints the element that was popped from the stack. In line 21, if the stack is empty, the else block, in line 22, it prints a message indicating that the stack is empty, and a pop operation cannot be performed. In line 24, the elif statement checks if choice is equal to 3, display. If so, it displays the stack elements as follows. In line 25, if stack. It checks if the stack is not empty. If it's not empty, it executes the code inside this block. In line 26, print stack elements. It prints a message to indicate that the following lines will display the stack elements. In line 27, L equals len of stack. It calculates the length of the stack and assigns it to the variable L. In line 28, for item in range of L-1, -1, -1. This for loop iterates over the stack in reverse order, starting from the top, index L-1, down to the bottom, index 0, and moving in reverse, -1, direction. In line 29, print of stack of item. It prints each element of the stack as it iterates through the loop, effectively displaying the stack elements from top to bottom. In line 33, if the stack is empty, the else block, it prints a message indicating that the stack is empty. In line 33, the elif statement checks if choice is equal to 4, quit. In line 34, if so, it breaks out of the infinite loop using the break statement, ending the program. In line 36 and 37, if none of the above conditions are met, that is, the user enters an invalid choice, it executes the else block and prints a message telling the user that their choice is invalid and to try again. The code continues to loop, allowing the user to perform stack operations until they choose to quit by selecting option 4. Now, let's see the output. Look at the first column. When we run the program, the menu displays the list of stack operations: 1. Push. 2. Pop. 3. Display. 4. Quit. Now the user enters the choice as 1. Enter element to push. 22 is typed by the user, so it is printed as 22 pushed onto the stack. Now the menu is displayed with the 4 options. Enter your choice. 1 is typed again. Enter element to push. 11 is typed, so it is printed as 11 pushed onto the stack. Now the menu is displayed with the 4 options. Now the user enters the choice 1 again. Enter element to push. 33 is typed, so it is printed as 33 pushed onto the stack. Now, look at the second column. The menu is displayed with the 4 options. Now, the user enters the choice 3. Stack elements displayed are 33, 11, 22. As 33 is the last in element, it is displayed on the top. Now again the menu displays the 4 options. The user enters choice 2. Popped element is 33. Do you remember the LIFO principle for stack? Last in, first out. The last element pushed in is 33 and the first element popped out is 33. Now look at the first column. Now again the menu displays the 4 options. The user enters choice 2 again. Popped element is 11. Now the second element 11 gets popped out. Now again the menu displays the 4 options. The user enters choice 2 again. Popped element is 22. Now the bottom element 22 gets popped out. Now, look at the second column. Now again the menu displays the 4 options. The user enters choice 3 to display the elements. Now, the stack is empty. The stack elements 22, 11 and 33 popped out one after the other and now the stack remains empty. Now again the menu displays the 4 options. The user enters choice 4 to quit. Program ends with quit option. Example 2. Write a Python program to display unique vowels present in the given word using stack. Now, look at the Python code. In line 1, this line prompts the user to enter a word and stores the input in the variable word. The input function is used to get input from the user, and the provided message, enter a word, is displayed as a prompt. In line 3, this line creates a list named vowels that contains all lowercase and uppercase vowels. These are the characters that the program will consider as vowels when checking the word. In line 4, here, an empty list named unique_vowels is initialized. This list will be used to store the unique vowels found in the user's input word. In line 6, this line starts a for loop that iterates over each character, char, in the user's input word, word. In line 7, inside the loop, this line checks whether the current character, char, is in the vowels list, that is, whether it's a vowel, and whether it's not already in the unique_vowels list. In line 8, if the conditions in the previous line are met, the current vowel is appended to the unique_vowels list. This ensures that only unique vowels are added to the list. In line 10, after the loop completes, this line prints the unique_vowels list, which contains all the unique vowels found in the input word. In line 11, finally, this line prints a message that includes the number of different, unique, vowels present in the input word. It uses the len function to calculate the length of the unique _vowels list, which gives the count of unique vowels. Now, let's look at the first output. The input entered is data structures in Python. It correctly identified the unique vowels as lowercase a, u, e, I, and o and displayed them in the unique _vowels list. Additionally, it correctly calculated and displayed that there are 5 different vowels present in the input word. Second time, we run the code and type uppercase letters. For the input stacks in Python, in uppercase letters, it correctly identified the unique vowels as uppercase a, I, and o and displayed them in the unique _vowels list. The program also correctly calculated and displayed that there are 3 different vowels present in the input word. Example 3. Write a Python program to create a stack called employee to perform the basic operations on stack using list. The list contains the 2 values, employee number and employee name. The program should include the options for addition, deletion, and display of employee details. Let's look at the code now. Line 1. This line initializes an empty list called employee_stack. This list will be used to store employee details, where each employee is represented as a tuple containing their employee number and employee name. Line 3. This line starts an infinite loop using while true. This loop will continue running until the user chooses to exit the program. Lines 4 to 8. These lines print a menu of options for the user to choose from. It displays options to add an employee, delete an employee, display employee details, or exit the program. Line 10. This line prompts the user to enter their choice and stores the input as an integer in the variable choice. Line 12. This line checks if the user's choice is equal to 1, which corresponds to the option to add an employee. In line 13 to 16, if the user chooses to add an employee, choice 1, the program prompts the user to enter the employee number and name. It then appends a tuple containing these details to the employee_stack list and confirms the addition. In line 18, this line checks if the user's choice is equal to 2, which corresponds to the option to delete an employee. In line 19, this line checks if there are any employees in the employee_stack list. In line 20-21, if there are employees in the stack, it removes the last employee, last tuple, from the employee_stack list using the pop method. It then prints a message confirming the deletion, including the deleted employee's details. In line 22-23, if there are no employees in the stack, it prints a message indicating that there are no employees to delete. In line 25, this line checks if the user's choice is equal to 3, which corresponds to the option to display employee details. In line 26, this line checks if there are any employees in the employee_stack list. In line 27, 28, 29, if there are employees in the stack, it prints the header employee details, and then iterates through the employee_stack list, printing the employee number and name for each employee. In line 30-31, if there are no employees in the stack, it prints a message indicating that there are no employee details to display. In line 33, this line checks if the user's choice is equal to 4, which corresponds to the option to exit the program. In line 34-35, if the user chooses to exit the program, it prints exiting program and exits the infinite loop by using the break statement, effectively terminating the program. In line 37, if the user enters a choice that is not 1, 2, 3, or 4, this line starts an else block, indicating that the choice is invalid. In line 38, inside the else block, it prints a message indicating that the choice is invalid and prompts the user to select a valid option. This program provides a menu-driven interface for managing employee details using a list-based stack and handles various user choices appropriately. Now, let's look at the output. Now, look at the first column. The program starts by displaying a menu of options. 1. Add employee. 2. Delete employee. 3. Display employees. 4. Exit. The user chooses option 1 to add an employee. The user enters the employee number as 2450 and the employee name is Sam. The program adds this employee to the stack and confirms. Employee Sam added successfully. Again, the menu gets displayed. The user chooses option 1 again and adds another employee with number 2452 and name Alice. The program adds this employee to the stack and confirms. Employee Alice added successfully. The user chooses option 1 once more and adds another employee with number 2454 and name Alex. The program adds this employee to the stack and confirms. Employee Alex added successfully. Now, look at the second column. The user chooses option 3 to display the employees the user has added. The program prints the details of all the employees currently in the stack. Employee number, 2450. Employee name, Sam. Employee number, 2452. Employee name, Alice. Employee number, 2454. Employee name, Alex. Next, the user chooses option 2 to delete an employee. The program removes the last employee, which is Alex with employee number 2454, and confirms the deletion. Employee Alex with employee number 2454 deleted. The user chooses option 3 again to display the updated list of employees. The program prints the details of the remaining employees. Employee number, 2450. Employee name, Sam. Employee number, 2452. Employee name, Alice. Now, look at the first column. The user chooses option 2 again to delete an employee. The program removes Alice with employee number 2452 and confirms the deletion. Employee Alice with employee number 2452 deleted. The user chooses option 2 once more to delete another employee. The program removes Sam with employee number 2450 and confirms the deletion. Employee Sam with employee number 2450 deleted. The user chooses option 2 again, but this time, there are no more employees in the stack, so the program informs you that there are no employees to delete. No employees to delete. Now, look at the second column. The user chooses option 3 once more to display the current list of employees, and the program confirms that there are no employee details to display. No employee details to display. Finally, the user chooses option 4 to exit the program, and the program displays exiting program before terminating. Thanks for watching. Watch the upcoming videos, Data Structures in Python, Part 3, infix, prefix and postfix notations. Conversion from infix to postfix notation. Evaluation of postfix expression. You can check the link in the description box given below. Please subscribe if you are new to my Sally and Bytes YouTube channel to stay updated with engaging content and never miss out on my latest videos. And don't forget to give this video a thumbs up.